The term cardiovascular disease refers to any disorders of the heart and circulatory system, such as coronary artery disease, hypertension, atherosclerosis, and stroke. It is one of the biggest causes of death in Australia, affecting over 18% of the Australian population.
One of the pathways that can lead to the development of cardiovascular disease is the breaking down of fatty acids.
So let's take a look at how some of these diseases can be developed.
Food is made up of proteins, carbohydrates, and fats. When it is ingested, lipids are broken down in the stomach into triacylglycerol. These are made up of a polar glycerol head and 3 non-polar fatty acid chain tails. Next, bile salts such as cholate and glycocolate are secreted from the gallbladder and into the small intestine. Here, they can emulsify in insoluble triacylglycerols to form micelles. These form due to the ambipathic nature of triacylglycerol, which allows these lipid molecules to arrange themselves in a spherical form in aqueous solution.
Micelles are then broken down into fatty acids and glycerol via pancreatic lipase.
However, once they are in the intestinal mucosa, they are transformed back into triacylglycerols. Triacylglycerols, along with apolipoproteins and cholesterol, join together to make chylomicrons.
Since they are soluble, they are able to move across blood vessel membranes and into the bloodstream. From there, chylomicrons can either migrate to myelocytes, the muscle cells where they are broken down for ATP fuel, or adipocytes for fat storage. Where there is excess potential energy provided by high-fat foods, the chylomicron gets stored in adipocytes. For this to happen, chylomicron is transported to the liver where it is stored in the adipocytes as fat droplets. Once in the liver, a chylomicron remnant gets broken down into cholesterol and then further into a very low density lipoprotein, VLDL. From there, VLDL is used to transport fat to the tissues where it becomes even more enriched with cholesterol to turn into a low density lipoprotein, LDL. Back in the bloodstream, LDL can become oxidized by oxygen. Oxidized LDL is recognized by the immune system and ingested by M2 macrophages, where it then forms lipid-rich foam cells. Foam cells are slow-moving but travel through the blood circulation to deposit in blood vessels, forming plaques. M2 macrophages secrete inflammatory mediators that cause the blood vessel to become inflamed and smooth muscle cells to proliferate. This proliferation triggers a fibrous capsule to form and surround the plaque, which causes it to harden. Accumulation of these hardened plaques leads to blood vessels becoming more stiff and narrow, resulting in obstructed circulation of oxygen-rich blood to other parts of the body. This is known as the disease atherosclerosis and can lead to serious problems such as hypertension, heart attack, and stroke. Another pathway that can lead to cardiovascular disease is the homocysteine pathway. Although this pathway may seem quite complex, it functions to convert methionine, an essential amino acid, from the diet into homocysteine, a building block of protein. The excretion of homocysteine is dependent on vitamin B6 to break it down into cystathionine. From here, it is further broken down into cysteine and then sulfate and water to allow it to be excreted through the urine.
The homocysteine pathway is also dependent on vitamin B12 and methionine synthase to recycle homocysteine to methionine and prevent free radical buildup. If a diet is deficient in vitamin B6 and B12, homocysteine breakdown and excretion is inhibited. This leads to a homocysteine accumulation in the blood and can cause LDL cholesterol to oxidize, as well as make blood vessel endothelial cells more susceptible to oxidative stress and damage, further leading to cardiovascular disease.
This pathway is also important as it is coupled with the folate cycle, which breaks down tetrahydrofolate into 5-methyl tetrahydrofolate. Without methionine synthase and vitamin B12, not only is homocysteine recycling prevented, but the folate cycle cannot continue, leading to folate deficiency. Hi, my name is Sam Thompson, and today I'm here to talk to you about the nutritional and exercise-related strategies that can lower your risk of obtaining cardiovascular disease. And what better way to start at your local fruit and veg shop? I'm here at the Earth Markets in Burleigh today, and we'll be discussing how the consumption of these superfoods can lower your risk of developing cardiovascular disease. Fruits and vegetables contain many vitamins and minerals that are good for your health. These include vitamins A, C, and E, magnesium, zinc, phosphorus, and folic acid. Research into folic acid shows that it may reduce blood levels of homocysteine, a substance that may be a risk factor for coronary heart disease, according to recent studies. Fruits and vegetables are low in fat, salt, and sugar, and provide a good source of dietary fibre. As part of a well-balanced regular diet and a healthy active lifestyle, a high intake of fruit and vegetables can help reduce obesity and maintain a healthy weight. It'll also lower your cholesterol and blood pressure.
But what can you do if you don't really like fruit?
Camarosa strawberry, which doesn't have the sweetness, but you put a crimson grape and it is shebang. So it's great for your milkshakes, bit of honey and pavlovas.
All right, I'll thank you very much.
It'll be like a lollipop.
It is like a lollipop.
Oh, it's amazing. You can put your
Wicked.
stick in there.
Why don't we head to the local fishmonger to find out how the consumption of seafood can decrease the risk of developing cardiovascular disease? While red meat intake has most consistently been found to increase the future risk of heart disease, the consumption of seafood possesses an array of beneficial effects. Although data are inconsistent according to a study conducted at the Johns Hopkins Centre back in 2003, one hypothesis is that a beneficial effect of fish consumption is due to omega-3 fatty acids contained in fish. Omega-3 fatty acids have a favourable effect on serum lipids and may also reduce the propensity to form blood clots. A reduced clotting tendency could explain why fish consumption tends to be more protective in persons already at high risk of developing heart disease. But wait, there's more! So why don't we head into the gym and find out how exercise can lower your risk of developing cardiovascular disease? How does exercise help heart disease? Well, exercise lowers your blood pressure, reducing the strain on the heart. It increases good HDL cholesterol that transports fat away from the arteries and back to the liver for processing. It may reduce levels of bad LDL cholesterol that form fatty deposits in the arteries and contribute to heart disease. It improves the circulation by preventing blood clots that can lead to heart attack and stroke. It increases fat loss, helps weight loss, and builds muscle mass. It also reduces stress by releasing feel-good hormones called endorphins. Stress and anxiety can slow the recovery from a heart attack.
So now that you understand how it can progress, ensure you make the right lifestyle choices to reduce your risk of developing cardiovascular disease.